So on this episode of Full Stack Engineering, we're going to talk about how I completely jinxed myself in episode number 2. So let's take a look at that clip.
I took a chance with an SSD since you've got no moving parts. I mean, unless you just got really unlucky and got bad flash in it, which I'm hoping not, because these are at least the higher quality drives. I'm hoping there's a less likely chance that there's going to be a drive that also goes down during that rebuild process or that resilvering process.
So yeah, this is how I had a 5 out of 6 drive failure with my Samsung 870 EVO SSD array that I talked about back in episode 2. I guess probably the thing to put out there is that is now, I believe, a known manufacturer, like a bad batch from the manufacturer. That being said, back in that episode, I built a 2x3 RAID Z1 VDEV out of those SSDs, and I had 6 4TB Samsung 870 EVOs for that. And because there was a bad manufacturing run, it sounds like, I actually did lose 5 out of 6 of those drives. It did take down the entire array. I did lose all of the data off of that array. Actually, I should quantify that. I lost the entire pool, and we'll get around to what that means in a minute. And long story short, after losing that many drives, I did decide to migrate off of Samsung at this point, and I ended up replacing them with Western Digital SA500s. So that being said, I went through the worst case scenario on that, and I'm not sure there was really anything that I could have done to prevent the situation. But that being said, even though I lost the pool, I didn't lose all of my data. And that's a really important distinction. I'd say I've got TrueNAS and ZFS to thank for that.
Before we get into the backups and all that stuff, do you want to unwrap what went on?
No, I'm busy repressing these memories, Avelino. This was terrible.
Because I remember when you were going through the problem, and we were so surprised at the situation of more than 2 drives failing at the same time that we thought it was a different problem. We didn't want to believe it was a drive problem, a drive failure.
Yeah, that's a good point too. So we started seeing multiple drives getting kicked out of the pool, and that was a really weird experience, especially since these are pretty new drives. These things are less than a year old. If I remember the calculation right, they had less than 13 terabyte writes on them. When you look at the TBW stat, they're guaranteed for, I think, like 2,500 terabyte writes or something like that, 5 years and 2,500 terabytes. And these things were at 13. So very, very low life on them. We were seeing sporadic read and write errors that were sometimes kicking the drives out of the pool. And so because there were so many errors coming up at once across multiple drives, it didn't feel like it was a drive issue at that point, and we ended up suspecting the controller. One of the things that we were doing to troubleshoot that is, if you go back and you see episode 2, I described this in more detail, and we'll link that in the description below. But just as a general overview, I have 2 units on 2 different controller cards. So there's a main server unit that's 12 bays, and all those bays are on one controller. There's another 12 drive JBOD underneath that, and that's on a completely different controller card. So I moved the SSDs from the NAS server down to the JBOD, and things looked okay for a little bit, but then those errors started popping back up again too. So it was really hard to tell what the issue was. We also suspected physical connections as well. So I did go through and check like some of the cabling. I also went through with alcohol, with IPA, the electronics grade IPA. So the 99% stuff that has a very, very low water content. So that's important when you're cleaning connectors and electronics. You don't want to have IPA that leaves any kind of water behind that's going to corrode things or mess with the electronics. So electronics grade IPA. I cleaned the connectors on the drives and kind of did the old Nintendo cartridge trick with them and kind of slid them in and out of the bays a couple times, just clean all the connectors off. And yeah, it looked like the issue went away for a little bit, but then it came right back.
And I know I might have at some point suggested that it could have been a controller issue. And that was mainly because I saw something similar in the past where I would see sporadic read-write errors or mass read-write errors at some point, and it turned out that one of the 3 SAS controllers in the JBOD were bad, and that was causing the errors on my end, which is why I gravitated to that, because the behavior was extremely similar.
Yeah, and that's a really reasonable troubleshooting thought too, because for drives that new, And these were the higher performance drives. You'd expect that they're going to be good for that period of time. So if you start seeing multiple issues in those troubleshooting steps, it's going to be a lot more unlikely that if you see multiple drive failures, that it's actually a drive problem. It's probably something further upstream from the drive, and the controller is the next thing upstream. So
yeah. And on episode 2, I think we talked about the silent data killer firmware corruption. And this is definitely a product of that. How important do you think ZFS is as a file system when it comes to data integrity? Like, if you didn't have ZFS to tell you that something was wrong, would you had found out?
Well, I would have found out when I lost all my data, that's for sure. I think the thing that ZFS gives you is confidence that your data is getting stored correctly. And then number 2, a practical backup and replication option. And that's really what saved me on this one, was having proper backups. Like, really, that's what it came down to. And so I had the entire SSD pool backing up on a regular basis over to just spinning Rust. So I had some really big drives over there that just run backups. And so it doesn't matter if they go slower, they just need to hold a lot of data, and just every night it goes through and runs a replication process and migrates everything over. So when I ended up just kind of rushing some new drives in to rebuild the pool, yes, I had to start the pool over from scratch, but I just hit the restore from backup button and everything came back off those drives. And I was back up and running pretty seamlessly. The whole process from losing the entire pool to completely rebuilding the entire pool on new drives, I think took about 4 days. But that also includes that happening over the weekend. So maybe 5 days. I saw the problem on, it was either a Friday evening or a Saturday morning. I can't quite remember. So I started doing some recovery. What I actually did was recovered the backups from the backup pool onto my spinning Rust pool. I recovered the SSD volumes over there so that I was at least up and running to get back to work on Monday. So all my stuff ran a little slower. It wasn't SSD performance. However, that's another great benefit of ZFS. It was using the ARC to host that stuff once it was warmed up off of the actual spinning Rust pool. It's warmed up in memory and that data is a lot faster to access. So yeah, I noticed a little performance hits when it was slow and everything, but when it was warmed up, it really wasn't so bad to work with. So recovered on the spinning Rust there. I got a whole nother set of the Western Digital drives on order because I'm not putting another Samsung pool back in that after this experience. The new SSDs obviously took a little bit to get in, a couple days, because you're, even when you rush them, you're going to have to wait a little bit for them. Once those came in, I threw all those in, set the pool back up, and then ran a backup from the main array, and then brought it back over to the SSDs. And it was back up and running no problem. I really didn't skip a beat considering what actually happened with those data pools. It didn't impact my work at all. It just set me back a little bit on my weekend.
I think this definitely shows the importance of having backups, having a backup strategy as part of your risk management. And it very much sounds like you didn't lose anything because you followed your backup strategy here. But let's say you didn't have that. Was there a way to recover any data from that pool?
That's the really interesting thing with what people say around RAID, and especially the software-based RAID. But if you lose X number of drives in your pool, you've lost the entire pool. That's kind of like the mantra, right? So RAID Z1, for example, you have one parity drive. So if you lose 2 drives, you've lost your entire pool. You've lost all your data. And I found out the answer to that is sort of, but not quite. It's not so black and white. There's actually a big gray area in there. What I was running into when these drives were going offline and it was kicking the pool offline and it was kicking a drive out of the pool, it has an error counter for each drive for read and write errors. And when it hits a certain number of these in a certain period of time, ZFS determines that the drive is unreliable. It's not going to be able to guarantee that the data getting written to or read from that drive is actually going to be valid data. So instead of continuing to just write corrupted data to your drive, it kicks the drive out of the pool and it says, hey, I'm not going to write data to this drive anymore. And so in RAID Z1, for example, if you've got 2 drives that get kicked out of that pool, then your whole pool goes offline, because now you don't have the right number of drives to actually be able to recreate that data from the drives that you have in the pool anymore. So one of the things you can do to clear out those read and write counters is to run zpool clear. And that zeroes it back out, and you can reconnect or re-online that drive back into the pool. So it looks kind of nice on the surface, but that was also one of the things that confused me a bit. Why are people saying that if you lose a certain number of drives, that you lose all your data? Yet when I have one drive fail, I can clear the errors out, online it again, and when I go look at it in a file explorer, when I go to load up programs or whatever, everything still seems to work okay. And so I think the catch to running zpool clear is not that your pool is back up and running and you have all your full data integrity and all that still, but I think the catch to zpool clear, it's kind of like opting out of the integrity checks, if you will. I'm kind of oversimplifying it a little, but I think it's really the tool to be able to online a drive again in an attempt to be able to get the last bits of stuff off that pool that you possibly can before the whole pool goes down. So if you've got a drive that's on the verge of starting to fail, it's having those intermittent failures, and it gets kicked out of the pool, you can use zpool clear to online it again. You should probably stop writing to the pool at that point, but then you have your pool online again, and you can have another attempt to try to get all of your stuff backed up off of that pool before you actually have hardware failures on those drives, like serious failures that keep it kicked offline.
This allows the individual to get a little bit creative in scenarios where maybe he just wasn't prepared for like disaster recovery. In the case of zpool clearing a drive, one can definitely, before doing that, turn off your array, pull out the bad drives, and DD them onto like a new known drive. So this allows you a little bit more time to try to recover in like such a creative fashion. It's those tricks that are good to know about, but best to not need to do them, you know?
Yeah, you probably don't want to be relying on that as your disaster recovery option. What I can see it as is it can be a really convenient method. So like I mentioned, having to recover from the backup pool that was a lot slower to do that recovery from. And so for example, if I can use zpool clear to kick a drive back online on the SSD pool, I'll be able to make that copy from one pool to the other a lot quicker if I'm trying to rebuild that SSD pool. Or if I've got two drives that happen to go down in that pool, instead of having to restore from the backup, I can try to clear the errors on one of them to be able to do a replace on the other drive. And if that comes back up, then I can do a replace on the next drive. And hopefully the SSD pool will rebuild itself faster by doing it that way, rather than having to go to a backup and rebuild that way.
That definitely sounds like a better trick to know of in that scenario.
Always have the backups. That's just so good to do. And with ZFS, the backups are pretty easy, especially with TrueNAS. TrueNAS is kind of like a UI and a control panel and dashboard over top of ZFS and some other tools. And it gives you a really easy way to go set up your backups. You just go into the tasks and configure it to replicate from one pool to the other, and it's really easy to do. And then after you set it up, it just runs automatically for you. So another catch to this is make sure that you're testing your backup recoveries periodically too, so that you actually do know how to recover and you make sure that those work in a disaster situation like this. To which I'll say I also do. Every couple months, every half a year or whatever, I'll just make sure that it recovers over to another data set or another ZVol, and I'll just go mount it up and make sure that there's some data there. And that's been a really easy process too, and every time I've done that, it's worked. So TrueNAS has made that a really, really easy interface around that, and it's great.
And if I recall, also the CLI API is very straightforward. Like it's not complicated at all. So if you didn't have TrueNAS as your UI, the CLI definitely shouldn't stop you from employing backups on a daily basis as part of your daily strategy.
Yeah, absolutely. I used the CLI to do some of this recovery because some of it got a little tricky. And in that process, I was able to use ZFS send and ZFS receive. And those were really easy commands to work with on the CLI. So one of the things in doing backups is you have to have snapshots for backups to work. Because what backups are doing are replicating snapshots of your data, not the current state of the data itself. And the other thing to add there is snapshots themselves are not backups. Snapshots are, well, I guess literally, they're a snapshot in time of how your data is on disk at that particular time. You can go backwards in snapshots and you're kind of going back in time that way. But if you lose your pool, you lose all of your snapshots on that pool. So snapshots don't help you recover lost data in that sense. You actually need to have a backup pool on another set of drives that all of that lives on.
And that makes sense because as you said, if you're snapshotting to the same pool, well, if you lose the pool, you lose those snapshots too.
One of the good things I learned about snapshots going through this, and Tom Lawrence has a really good video on how snapshots are copy on write, and that was a really good video to get some of these concepts too. When I was originally setting up the NAS, one of the things I was concerned about is that every time I took a snapshot, that I would need that full amount of space for every single snapshot that I took. So I take a snapshot at this point in time, it's going to take, say, 3 terabytes to snapshot all the data in this one location. I go take a snapshot again in a week, it's going to take another 3 terabytes of data to snapshot everything. And the cool thing about this is ZFS actually doesn't work that way. It's a lot smarter about how it takes snapshots. So snapshots are only recording what has changed. So your first snapshot is like this base of everything is in this current state at this time. ZFS is a copy on write file system. So every time you make changes to one of those files on disk or to the blocks on disk, it only needs to track the things that changed essentially. It only needs to track that data that got written. So the next snapshot you take isn't going to be the whole drive again. It's just going to be the tiny little bits that changed. And then the next snapshot again is just the new tiny little bits that changed.
And to clarify, this isn't deltas either. It's the same file copied over again, the entire file with the new changes, of course, but it's that entire file.
It might not even be entire file. It might be better to think of it in terms of blocks. And this is a part where don't quote me on the mechanics of this because I haven't dove too deep into it, but I think it probably does this at the block level. So if it sees a new block of data get written, then it's going to store that 4K block or that 32K block or whatever you set your block size to. That's probably how it's doing it under the hood. The cool thing about that is that means you can start taking daily snapshots, for example, and you're not going to fill up your entire pool that way. If nothing happened to change that day or there were just a couple tiny little changes, you're not going to have another giant chunk of terabytes that has to get stored. You might have 0-byte snapshots in a day, and you're not really using up any extra space. And that's pretty cool. You might be saying like, well, what's the trade-off of snapshots? Like, this sounds amazing, and it'll just store everything you need forever. Well, the catch is if you don't roll snapshots off of the end, you'll never reclaim data after you've deleted files. So at some point, you probably want to delete snapshots after a certain period of time, just so your pool doesn't grow indefinitely.
And that makes a lot of sense because that base layer has references to all those blocks, all those inodes, if you will. But let's say like as time moves forward, you've gotten rid of a lot of that stuff. Popping off those snapshots at the end will allow to do just that, reclaim some space. Of course, not all of it, obviously, but some of that is no longer in use in any of the forward snapshots.
Yeah, and so for example, if you write a file on the first day and then the next day you go delete that file and you have daily snapshots on a 30-day retention policy. So you get one new snapshot every day. And after 30 days, the last snapshot on the stack gets deleted and rolls off. Then when you've written that file and you've deleted it, you don't actually get the space back until the snapshot with that file goes away, which means you have to wait 30 days to get that space back. So that's kind of the trade-off for how long you retain snapshots. But that being said, that's such a handy feature. So like a catastrophic failure, like you lose the entire pool, you're going to lose all your snapshots. But if you have like a data corruption issue, so I've had it a couple times where I've had a VM running, for example, and I'm doing work inside the VM and something just crashes. And I actually have to do a hard reset on my workstation. Sometimes that can just blow out the VM and that VM just doesn't want to come up anymore. That's been something that's been really nice to have those daily snapshots for. I can bring up the last snapshot and remount that as the iSCSI device that it sits on, and the VM just comes back. So I've got that entire iSCSI drive looking just like it did yesterday, and everything just keeps working again. So that's been really, really nice. Another thing you could think about using snapshots for is if I've got a bunch of users on my network, can I use snapshots to recover data that they might have accidentally deleted? Or in my case, can I use it to recover data that I've accidentally deleted? On one side of things, yes, you could absolutely use snapshots to do that. There's no technical reason why you can't do that with a snapshot. So you could go back to a snapshot a couple days ago or a week ago or something like that. So you kind of like restore that snapshot to a new data set or a new ZVol, mount that up as read-only, be able to pull that up on a workstation, find that person's file that they lost and copy it over to their computer, copy it over to a flash drive and give it to them, whatever. Technically, you can do that. The thing that I personally don't like about that from an admin perspective is it feels like using the wrong tool for the job and putting that pressure on the administrator to solve the problem of a user screwing something up. I think that could unintentionally invite people to be more reckless with their files and feel like they don't have to be careful with their data. And that might just put more pressure on you as an admin to have to deal with that. I look at snapshots as a way to recover from technical problems. Like I had to hit the reset button on my machine because there was a hard crash. And if I didn't have ZFS, if I was still just running off of a single disk on this machine, that might actually have file corruption on that single disk. And I might have to go run check disk to fix it. Maybe it fixes it, maybe it doesn't. And maybe that VM is dead, or maybe just parts of that drive are just corrupted, and that's just what I have to live with. And I think that's the cool thing that ZFS snapshots let you back out of from an administrator perspective or from kind of like a storage perspective. If you have one of those technical issues, you can roll back to the last snapshot and it looks like there was no hardware issue that happened at all. You get your drive back right in the state that it was supposed to be at. So I look at that not as like I'm trying to recover an individual file. It's like I need to get yesterday's drive back in my machine because today's drive just completely blew out in some way. One of the ways that you can do user recovery is on my iSCSI mounts, I just use the desktop Backblaze client. And I have that backing up my iSCSI shares locally. So like my workstation doesn't actually know the difference between a drive in the computer and a drive on an iSCSI share. So I just have a local Backblaze client that backs up all of that stuff. And so if I need an individual file that I've lost, I can just go to the cloud client and do a cloud restore and say, hey, bring me this one file back, or, bring me these couple files back. And that's a pretty easy way to deal with that. It also gives me an offsite storage mechanism so that if anything happens to my drives on site, I've got yet another backup of them.
Yeah, I was just going to say that seeing people out there employing sane disaster recovery strategies is great. And here you have on-site recovery strategy and an off-site. Off-site is obviously for your worst case scenarios. But let's say that the pool that your snapshots live on does die and you can't recover for X reason. You have off-site.
Absolutely. Now, the catch to off-site is it's a lot more expensive. Not only as a monthly cost, but the other thing, depending on the type of service you're paying for, you could end up having to pay for the download as well. Now, the Backblaze desktop client for an individual computer doesn't make you do that, but I also have Backblaze on the NAS, the business-to-business plan. And if I remember that one right, you do have to pay for what you download from that. The other downside to a download is it's going to take a long time to download that off your internet connection. Now, if I remember Backblaze right, they can actually send you a drive with your data on it if you want to recover that way.
I didn't know about the latter option, but that's definitely good to know.
And that being said, in all of my computer history, I think I've had to download from a cloud backup twice. Like I've done a complete recovery from a cloud backup twice. It took a really long time to do it, but it worked. That was also before I had ZFS. And so now that I have ZFS, one of the really nice things about this particular disaster that I ran into, because losing an entire pool was a pretty big disaster. In fact, losing 5 drives at once, I think, is the most amount of drives that I've ever not only lost at a time, but I don't think I've lost 5 drives in the last 10 years. This was big.
That's true. I think in the last 5 years, I've only lost 2 drives, and these are mechanical.
So the cool thing with ZFS and the way that I've got it set up now is I added that backup pool in, and now I was able to just recover off the backup pool and not even have to touch the cloud backups. And that was really nice. Even on the spinning Rust, it still recovered way faster. And it was just such an easier process than trying to do a cloud recovery. Well, that's all I got. We'll catch you all next time on the next episode of Full Stack Engineering.